Hello, welcome to an episode of Flying High with Flutter. I'm your host, Alan Wyma. Today I am with Brian Cardarella, who is the CEO of DockYard, a consultancy mostly focusing on Elixir. Welcome, Brian. How are you?
Hello, everybody. I'm doing well. Slowly recovering from ElixirConf.
Yeah, we're really hot off ElixirConf, right? So this is recorded on the 7th of September. ElixirConf, ended last week, I think, right?
Yeah, last day was on Friday. My talk was on Thursday, so it was less than a week ago. I also went down to Austin on Friday and saw some friends and had a fun time down there. So my recovery time is probably a little bit more extended than others that attended the conference at the moment, but we're getting there.
Okay. Yeah, there's a lot of exciting stuff coming out of DockYard, right? So maybe I'll let you kind of take over and talk about what stuff came out and maybe end with the main topic for this episode.
Yep. So the projects that we've been working on, I went over during my sponsorship keynote, which I don't know if that is recorded, but the four primary projects that I mentioned are first Beacon CMS. So Beacon CMS is a LiveView based content management service for Phoenix applications. And a lot of people may wonder why we need another CMS. And I would say that you don't need another CMS. If you have one already, then this isn't for you. This is for people that are at the kind of decision-making point on whether or not they go with Phoenix. And what we've seen being consultancy is that sometimes when the technology in question does not have an off-the-shelf solution, many companies will be a little bit more reluctant to go with it. And very often, and for very good reasons, marketing departments want a way to easily create, edit, and remove marketing landing pages. And that's why they go with Drupal. That's why they go with WordPress. So when we are implementing these sites for clients, it's a shame when we build this nice, beautiful, Phoenix LiveView application, and then in certain cases, we have to find ways to either proxy out pages to a WordPress thing or pull in from a WordPress API so that they can still, it just becomes a mess. So the Beacon CMS, the way that we kind of envision it working is that the pages themselves are all being served up with LiveView. So, crawlers still get all the benefit of server-side rendered dead view pages for SEO purposes. And, coming from the single page application world, I'm very much aware that Google now executes JavaScript in browser and it crawls it all properly. But, there's still many that don't. And then the users get the experience benefits of, the performance benefits of a LiveView built page. These pages through an admin interface are created and edited at runtime. And so we have a built-in compiler that will actually compile these templates, LiveView templates at runtime for use. And we essentially have what your router ends up looking like in Phoenix is here's the Beacon CMS endpoint, points to that, it takes over, and then it manages all the delegation out to the properly rendering the page. There's a data layer that will probably match up the path for setting up which data is available on a given page. And then finally, something that is going to take us probably the longest period of time to build out properly, at least the way that I have it in mind, is a page builder. And we're leaning very hard into Tailwind CSS for this. I essentially would like to have a LiveView built page builder that is drag and drop components. Our acceptance criteria for this is that a non-technical person should be able to build up pages very, very quickly. At DockYard, the worst project at DockYard is Dockyard.com. Like, it has been the worst project for just years and years and years, and it's probably the most overbuilt CMS that's out there. At one time we had Phoenix API as the back end. Technically still the current DockYard production site is this. Phoenix API is the back end and Ember.js is the front end. And so it's a massively scalable content management site that has, this crazy overbuilt front end to it because these are the tools that we were using and we were building with. But I don't even want to think about how much opportunity costs we've poured into it over the years. So I've hit the eject button on it. We're building out Beacon CMS. We plan on relaunching Dockyard.com with it in November. And at that point, I think we'll be in a good position to say, okay, now others can probably start building content sites with this. And we're very quickly working on a hosted version of this as well. There are some limitations currently in LiveView that we're hoping to address. For example, you can't add new host names at runtime as far as a LiveView application point, being able to serve up pages associated with that given host name. And this is it's not an oversight. It's just that no one's needed to do that before, and it just wasn't accounted for. I've spoken with Chris McCord about it, and he's open to us ideating a way through that. So we're going to be looking at that hopefully soon. But the next project is Dockyard Academy. And I've always been resistant to DockYard getting into the education game because corporate training, we've done it before, but we were never very effective at it. And I'd rather have focused on like pure consulting rather than trying to split our people and saying, hey, this week you're going to be on training and that next week you'll be back on billing. It's not a very good explanation, but I just didn't really have a good path forward to us providing quality education services in the past. But we ran this survey a few years ago, the Elixir Ecosystem Survey, and we need to run it again. We just haven't, especially because I want to see where things have moved over time. But one of the things that came out of the survey, actually this kind of influenced a few of our decisions for R&D projects. I asked in the survey, questions such as if your company has decided not to use Elixir or was using Elixir and moved away from it, what were the reasons? And one of the top reasons was always talent availability. And we even feel this at DockYard. I mean, we probably have, I don't want to toot our own horn, but I would like to think that we have an easier time sourcing and hiring Elixir talent than most of the companies do, just because we have a recognized name. And we're still looking at probably a longer lead time than we've seen for any other technical capability over our company's lifetime. So to that end, I recognize that this pain is real, and stakeholders within companies will decide to go with what is a lesser technology if it's going to be less costly or faster for them to build a team around it. The value proposition of managing a distributed system and all these performance benefits of Elixir and Phoenix mean nothing to the person that's paying the bills if an application gets built up and they can't hire a team to maintain it and keep it moving forward. They'd rather go with a more run-of-the-mill solution that perhaps sacrifices on some of these other things that we believe Elixir brings to the table if they can go out and easily build up a team. Because opportunity cost is the most expensive thing to companies at the end of the day, not technology cost. So to that end, I kind of look at the Elixir talent pool right now out there as being inverted, meaning that we have so many high-level seniors in terms of percentage of the community. And this is probably a bit of an artifact of just Elixir being really a language that engineers have transitioned over to, as opposed to being their first language. I've met a few, but it's very few and far between that people say, hey, look, I'm learning Elixir, at my first job. I saw this all the time with Ruby. I saw it all the time in the JS ecosystem, but it really has not been a thing with Elixir. And so we decided, hey, is there something we can do about this? So Dockyard Academy is a 3-month education course that we will be providing guided education content if you come through us for it, but we're also giving away the content completely for free. It is, I think it's, the URL is academy.dockyard.com, but there should be, we just put up extremely basic marketing landing pages for ElixirConf because we just were in a rush to get everything done. And so that's one of the complaints we've seen, that all of our, the websites are pretty sparse, and they are, because if we had more time, we would have flushed them out, but we just didn't. But there should at least be a link off of that, I believe, to the GitHub account. And the GitHub org should have all the content. The curriculum, I believe, should be open source. And if companies want to take this and stand up their own internal training services, please go ahead and do so. We're probably going to discourage like a Code Academy type thing from taking our content and billing off of it directly. Like this isn't going to become someone's product. But if another consultancy wants to do it and run their own like small training, but like if their primary business is not training, we recognize that if we kept it to be our thing, people had to come to DockYard to access the content, then we're not really meeting the goal and purpose of the Academy, which is to create new Elixir engineers. At best, our cohort size will be 10 engineers, and we only plan on running 3 cohorts per year. So we can only, in an optimum situation, produce 30 new engineers annually. And we recognize that there's attrition during these courses too. So, I mean, we may be really looking at like 15 to 20 engineers at the end of the day that we end up producing annually. That's not enough. So it's in DockYard's best interest. Our horses are so tied to hitched to Elixir at this point that we recognize that it's in our best interest to grow the ecosystem, even if we're not directly benefiting from all of those efforts. Because there's a much larger picture where if Elixir is successful, then I believe DockYard will be successful. That's essentially how I've set up our profit motivation around this, is that it's more of a long tail thing. Rather than profiting directly off the Academy, we're trying to get to essentially cost neutrality on it. You know, we want to be able to recoup the costs of producing the content and the costs of running the cohorts. So we will have a price associated with coming through our guided side of it. And there's benefits to that too, in that after the 3 months, we'll be selecting engineers out of the cohorts to join the DockYard practicum. So a 3-month paid practicum being on client projects. We won't be billing out their time, but we will be pairing them with more senior engineers. And then from there, out of that pool, DockYard can recruit directly for our engineering team, or we would be looking to pair them up with current and past clients that are interested in that. So not a recruitment like service, more of a, it's an education career building service, I guess, is one way to look at it. And we really want to focus on junior engineers. We've had a lot of people come up and say, hey, we have so-and-so from our company. They want to learn Elixir. Can they come? This person's like a senior Java engineer or something, and that's not really the candidate. Those aren't really the candidate types that we're looking for to come to DockYard's guided service. So if you want to have that engineer go through the course, they're willing to, fork the live book and run it themselves. But we're going to be interviewing all the proposals and trying to find, really people that are at the beginning of their career that want to make a career for themselves in software development and hopefully through Elixir. The next project after that is NX, and this is not a DockYard project per se. It's really one that we are helping sponsor. And for those that are listening that may not be familiar with it, NX is Elixir's machine learning effort. And so there are a few projects that are under the NX umbrella. But Sean Moriarty, who is one of the lead engineers in this effort, we're sponsoring his work on this project. And then finally is, we have Firefly. I'm trying to remember my slide deck in the order that I did everything in. Firefly is a rename of another project that we released, I'd say too early, a few years ago, called Lumen. And it is we're basically rebuilding the beam in Rust to compile and target WebAssembly. The reason for this at the time was I was interested in exploring running Elixir in the browser. We were transitioning away from Ember for many good reasons. I needed to dump it. It was just killing us as a business. And but the question was left, what are we going to do on the front end now? LiveView was in its infancy at the time. And so I wasn't sure really what the future of the client was going to be at DockYard. We were assessing a couple different web frameworks. We really like Svelte. but it also at the time it was not where it is today. And so I thought, hey, if we could do something with building up a web framework in the browser using Elixir through WebAssembly, that might be interesting. My interests since then have shifted, and a couple things are now, I think, the most likely use cases of Firefly. To me, number one is IoT compilation. So one big issue with Elixir in the IoT space is that Nervous is a great project, but you're looking at a 20 megabyte minimum footprint for your binaries because it's compiling Erlang. And Erlang was never built with the intention of having a small footprint. And for IoT devices, this is just way outside the bounds of memory that they're willing to put on chip. So we are looking at hopefully a sub 1 megabyte compilation size for Firefly, and we're able to achieve this by removing some things that are unnecessary for these contexts. So one thing we had to sacrifice on is hot code reloading. Hot code reloading, for those that don't know, allow us to kind of like sideload in code into production applications. And essentially you're sending deltas. But in order for your code to support that, it has to carry a lot of annotated information. And this adds bytes to the binary, adds a lot of bytes to the binary. Second is dead code elimination. And there will be additional optimizations beyond that. Fortunately, Erlang, for good reasons, it's not a strongly typed language, and there are many instances of areas that become very difficult for us to manage under dead code elimination. Gen servers heavily rely upon the apply function, which, for those that don't know, in Erlang allows us to dynamically call a module and function at runtime. And so when you are dynamically calling functions, then doing static analysis of that code is a significantly more difficult process for determining what you don't need, because you may not know what you don't need if runtime you're calling something that was not specifically declared in the code. So finally, this brings us to LiveView Native, which is the subject of this particular podcast. So do you want me to kind of give the spiel on LiveView Native first, or were there questions you wanted to start out with?
I think it's good to really make it clear about what is LiveView and kind of what makes it different. I think you brushed over a little bit. Because not everybody, actually, we talked about in the past, but not everybody, this is every single episode.
Yeah. This is a Flutter podcast. This is not a Elixir Phoenix podcast. Sure. Okay.
We have had some Elixir people actually come on, so it's not like it's all brand new, but it just depends if you listen to that episode or not.
Yeah. So LiveView is essentially born from frustration, and for the frustration being how insane it is to build up complex applications in JavaScript nowadays. And I can say this for certain. I dedicated, we were without a doubt the world's largest Ember.js consultancy. There's no kind of subjectivity there. We that technology I felt like had a lot of potential, very little follow through, and we saw the frustration that existed at times when it came around estimation, when it came around long-term maintenance, when it came around actual feature build cost. And these are not specifically Ember problems. These are really client-side application problems in the JavaScript space. We were, as a consultancy, and me as an engineer, my career started really in the Rails space. I had a few jobs before that doing C-level development on firmware. I worked for American Power Conversions in their R&D office in East Providence. I did a bunch of other things, but I'd really say my real career trajectory took off when I first got into Rails. And I got into Rails pre 1.0, very early days. And the value proposition that really grabbed me at the time with Rails, I don't think this was ever directly said, but it was implied, because the comparison at the time was to Java and to PHP. And so the kind of idea was that Rails was interesting because you could build what you would build otherwise in those competitive technologies for half the time and half the price. It was, you could kind of make it as widely labeled as that. It was just a less costly in terms of time, which directly goes back to price, way to build out similar solutions. Now, there's a lot to be said on the the boundaries there being that I think we all accept that Ruby is not as performant a language as Java. And I think, in light of what Facebook's been able to do with PHP, that has, better performance benefits. All the technical reasons why Ruby shouldn't be chosen are there, but none of that mattered. It was easily, junior engineers could get it, do it very, very easily. You could build up teams around it very, very easily. You could deploy and build features faster with it. That's what mattered. And so we were working under those conditions for years, which is nice. But then come along the single page application frameworks, and like the idea of what they were trying to do made sense. Running a complex logic in the browser to reduce interaction times, I thought was a good idea. However, the reality of it is we were going from all the benefits of Rails over to a situation now. I would joke and say we can build the same features for twice the time and twice the cost, and they were just flat out more expensive. The value proposition, the value of what you get for having a client side interaction as opposed to a server side interaction was diminishing returns. So if you're a company like LinkedIn, if you're a company like Instagram or Facebook, if you're a company that has these deep pockets and are willing to just blow all that money on engineering costs, then yeah, you can go and build these client-side applications and make them really, really nice. Because that 1% advantage that you may have in terms of user experience and be able to close that gap, that may be worth a lot of money to your company because it's such a big company. But for most, what we're seeing a lot of startups, a lot of even mid-tier companies, that was not really worth it to them. This is why I feel like in many ways, and there'll probably be many that disagree with me on this, but why frameworks like React ended up beating out Ember, in part because it was just faster to get going. It was faster to play around and jump in and out of things. Like Ember kept you guided on those rails. That's not the right term I should be using, but it kept you guided and on the same track. And so I felt like Ember was always a superior technology to React for the proper way to build an application, but you have to get there. And that getting there takes time. And if you don't have the resources to get there, you've lost your opportunity to really make an impact in the market. So to that end, Chris McCord, who created and is the creator of the Phoenix framework, which is a web framework in Elixir, he by his own admission, he just does not like JavaScript. And so he was working at DockYard at the time, and he worked for us for about 5 years, I think. He saw these problems up front. He saw what we were building. We were using Phoenix essentially as an API service, and we're building all the front ends out with Ember. And he and Jose Valine, being the creator of Elixir, they thought there might be a better way to do this, that they could manage the state of the application server side, which is exactly what Elixir is meant to do. Elixir is meant to be this massively distributed system that manages state in the processes, and the processes are super cheap. And so a given Elixir server can serve and manage the state for potentially millions of connected individuals. So they experimented a bit, and they found a way to start. Well, I think it really took off when they found the MorphDOM JS library, a very lightweight, not exactly a virtual DOM, but kind of in that same vein where it allows you to send very small deltas of DOM updates and patch those into the DOM. And so it just became a matter at that point, okay, how do we track these changes server side, and how do we produce and send these changes over? And then you expand upon it by adding events that allow you to communicate from the client back to the server. And that's really where LiveView began to take off. And I can say definitively that it is a much better experience for building up complex web applications. And from the user's perspective, because Phoenix is so fast, the interaction times are transparent. In many cases, unless the server's on the other side of the planet, you're not going to notice the latency of pressing a button and receiving a response, because it's an open WebSocket connection. So you're not making a new It's not a whole new API request. You have that socket already open. The latency and overhead of the data flowing back and forth is minimal. And on top of that, Chris has since gone to a company called Fly.io that specifically manages distributed data centers and they, why they wanted to employ Chris is because of LiveView. LiveView's big knock was always, the latency of the response if the server has a physical distance from you. Okay, Fly solves that problem rather elegantly, and so now the kind of challenge that existed at this point was, okay, is LiveView just going to be for the web? And I think a lot of people over the years have independently come to this conclusion themselves. I've seen, not that they felt compelled to build this, but I've seen a lot of people mention, or at least ideate on the potential of using the programming model of LiveView to produce native applications. I go over this in my keynote talk, but when I left DockYard, and the irony of it is I spent 10 years building a consultancy that was trying to sell building web applications. And we went pretty hard into progressive web apps and trying to sell that, okay, progressive web apps have all these values against native applications. And then the moment I leave DockYard, the very first product I'm creating, I needed a native application developer. So the nice thing that kind of came from that, though, is his first, this was probably spring of 2020, so a few months into the pandemic at that point. That native developer wanted to try to do it with Swift UI. Now, Swift UI has been an evolving framework at Apple, and I think because it was released in kind of a very simple state, it probably had burnt a few people early on, and they, the practical engineer will say, we can just go back to Objective-C and UIKit has everything we need. Yeah, but it's not like the future that Apple's hoping to build up. And so I saw, one of the nice things that Swift UI had is its view components are all composable. And so this maps very well to DOM. And we are essentially reproducing how Morph DOM works in the web, but we're doing that in the native client. And so I want to be very careful that a lot of people have mistakenly thought that essentially what we're delivering is a web view, like a packaged web view. That's not what's happening here. We are making a connection in Swift, back a WebSocket connection using a Swift implemented channels client. We establish a LiveView connection. We get the dead render being just the server-side render of the page. We extract out the LiveView fragment. We make the LiveView connection at that point. We establish the connection at the endpoint. And then we are receiving the diffs and we're merging them into our own VDOM instance that we're managing in the client. And on every single patch update, we walk that VDOM and we produce a new Swift UI view tree of native components. And so we have a very simple goal. For every single Swift UI component that exists, we will have a one-to-one naming parity of the corresponding element name you're supposed to use in LiveView. And LiveView templates are essentially, whether you want to refer to them as HTML or XML templates, they're essentially just markup templates. So the text Swift UI component, for example, capital T text will just be lowercase t text element name. And then modifiers in Swift UI become attributes on the element. And the content of that text element, same deal as on the web, becomes the content of like a span element. Parents and children, children will be embedded within the parent and so on. So we're trying to provide the similar experience for building applications through LiveView on the web, but now applying it to pretty much everywhere else. Because when we start to go native, it can get a bit unwieldy. Like on Swift UI, Apple wants this everywhere. So we can target not just iOS devices, but we can target Mac OS desktop applications. We can target tvOS applications. We can target watchOS applications. Now, I understand there are limitations as to what and how Apple wants some of these applications to be built, but just to say that there is a path forward for us doing this now. And beyond just the Apple ecosystem, we have a Jetpack Compose client that's about 3 to 4 months behind the Swift UI client. Jetpack Compose is Android's, I'd say, mostly new UI framework that has similar features to Swift UI in that it's a composable component-based framework. The great irony here is that despite LiveView Native being a response in some ways and a way to compete with React Native, I don't think it could have existed without React Native, because as I understand it, and I could get this part of the history wrong, because I'm very knowledgeable on the anecdotal history on a lot of web stuff, moving over into native space I'm realizing there's a lot that I still have to learn. And we have we're DockYard as a consultancy. We're known in the Elixir space. We're still probably known in the Ember space, and maybe some people remember us from the Rails space. But outside of that, nobody knows who we are. And so it's easy for me to tap the right people in Elixir land when I need to ask a question. When we're moving over and doing Swift stuff, we're starting from zero. I've been fortunate that I've been able to find some good people that have been good resources for us. But I'd say that by and large, because we are such a small company attempting this, we are definitely climbing up a pretty big hill, but we're dedicated to seeing it through.
Yeah, it's pretty exciting. I was playing around with it, and I think the big question I have is, because I think how does it work on a technical side? Because you're somehow programmatically reading this HTML or XML-like language and then creating components, right? So you're not actually compiling something. Are you just kind of parsing and then creating something? I'm just kind of curious how it all works.
Yeah, well, okay, so everything happens at runtime. LiveView itself, it essentially produces a way for you to hold a text-based fragment of an HTML document and then patch in Delta updates over time. That's essentially, that's really what Morph DOM does. And LiveView provides the interface for providing those deltas and those diffs. And the diffs are super small in size. They break up the elements. I think there's actually still an optimization above that. But right now it's literally splitting up the elements on the markup text itself. And so you may see the open on a given diff, you may see the open caret of the element name as being one part of what's broken up, and maybe the element name itself is what changes. Kind of an abstract example, but the point is that it's very small amounts of information coming over the wire. It comes over very fast. So we hold the text representation of that in memory, and when those diffs come in, we have a way of patching it back into that text representation, and then we parse that fragment with in Swift. It's called Swift soup. And I think on the Android side, it's something else soup. So I don't know where the soup name comes from. That seems popular. Anyway, we parse that into objects, and then we walk and we just look at each. I think we do a depth first walk of it. So we walk our way back up. But we essentially look at this element name. We have a registry corresponds to this component name in Swift UI. So text to text. If something is camel cased in Swift UI, it's going to be hyphenated case in our template. And so we just instantiate and we pass in the given arguments, and we continue to go up the chain. We build up parent, 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 parent. And then at that point, I really can't tell you what happens because Swift UI as a framework is closed source. We hand off the view tree over to the Swift UI content view. And thankfully, it works, because if it didn't work, we kind of would have been lost as to what to do, or been a lot of work of poking and prodding to see what effect things would have. And that's kind of the disconcerting part of what we're doing from my perspective. Working in web technologies for so long, I've just become accustomed to being able to look at every single thing within the stack of what I produced if I needed to. If I wanted to go down to the operating system level, I could. If I wanted to, tear apart a given framework, I could, to see exactly what was happening and find ways for us to better use it. But Swift as a language is open source. Swift UI as a framework is closed to source. So we are kind of left a little bit with some mystery there as to exactly how Swift UI is tracking changes, how it's doing its own merging into its own view. Like it takes, a component view and it's merging into its own tree at some point. And I have to assume that it's deciding what it merges in, what it doesn't, based upon the state of it, or what declares an updated view at that point. It's difficult to tell. We were fortunate enough to be able to talk with an engineer early on by the name of Max Desiatov. And for my money, outside of the Swift UI core team, he's probably the most knowledgeable person on that effort outside of Apple at the time. I say at the time now because Apple has since gone and hired him. And so now he's been brought into the fold. But he was running a project that was reverse engineering Swift and Swift UI to compile into WebAssembly. So I would say, no, Swift itself wasn't being reverse engineered because it was open source. Swift UI was being reverse engineered to compile into WebAssembly to presumably build WebAssembly compiled applications for the web using Swift UI. But Apple scooped them up recently, and I don't know what the state and future of that project is at this point, because I know that he's had to move on from it now being at Apple. But all this to say, we were able to connect with him early on, and he gave some really good advice on how the implementation of this should be for performance reasons. We were originally going to go with the Codable protocol in Swift that allows you to take a document and basically produce objects from it. And there were examples of people using JSON documents and updating those JSON documents to produce Swift UI from it. That seemed like a path forward for us at one time, but when we started to explore it, it wasn't viable. And Max mentioned that Codable is rather slow at times. And so our best path forward was to just re-implement what MorphDOM was doing on the web, where we just hold the VDOM, walk it. And I mean, it shouldn't surprise anybody because Swift is a compiled language and it's super fast, but it's blazingly fast. So just to stress test it and to see if we could produce any type of back pressure. It was on a local machine, but it wasn't, this is not a latency test of the network. This is just a stress test of the Swift UI render tree, rendering function. But we were able to send updates every millisecond over, and there was no problem. Like Swift UI handled it like a champ. I can't speak to the render performance on Jetpack Composable, but I keep calling it Composable, Jetpack Compose. But I imagine it's going to be similar. I mean, these are compiled frameworks running at runtime, and so they're going to be super fast. Performance is not a concern for me at the moment, outside of just the normal latency issues of network connected devices.
Now, are you planning just to stay with these two platforms only, or you think it's actually get into, desktop for Windows can probably be pretty big too, right? Because you have enterprise clients, etc.
Yep. So we don't have one started, but we are actively seeking out a WinUI 3 developer. I went through, I haven't done Windows development in such a long time. I mean, I go back to, the VB script days and whatever I was doing back in the 90s. So I was essentially starting from zero in my research as to what we should be using there. And I'm erring on the side of something newer because this is such a new framework. We're still going to be looking at some time to when it is production ready. So I'd rather grow alongside a newer effort that is the future in these environments. So Swift UI made sense on the iOS side. Jetpack Compose came along at the right time. And I believe the Jetpack Compose might be a year out at best at this point. I forget when it was officially released. I know it was out in beta and you could test it for a while. But on the Windows side, it seems like WinUI 3 is the newer framework. And the nice thing about it is that it's XAML or XMAL. I don't know the acronyms in the Windows land, but it's essentially an XML document. And again, composable. So that's a big thing for us, having a composable UI framework, because now it's a structured document that we can walk and we can, very easily represent this on a LiveView template. But we haven't made any efforts there just yet, just that I've already identified it as our next client that we want to implement. And we're actively hiring or looking for a partner company that may be interested in this project that has a WinUI 3 developer that wants to get in on this. The other thing that we have to do too is right now we have common logic that's implemented in the Swift UI client, that's implemented in the Kotlin Android client, presumably will be implemented in the C# WinUI 3 client. So we need to extract this out to a common library. And just yesterday, one of my engineers, he's going to try to do this in Rust, where the morph DOM implementation of the merging and the patching of the diffs into a structured document is the first pass. If we can extract this out to a common library, then we've actually made it easier for others not on the LiveView Native core team to produce their own client. Like if they don't have to go through the whole process of doing the client in the merge logic, which it's a heavy lift at times. Probably going to be 80% of the work of implementing a client, maybe 70%, depending upon like how deep you want to go with covering the client UI components. But if we essentially provide that logic as a linked library or some sort of common LLVM compiled target that you can include in your project, then you write your wrapper around it, and now you have a much faster path forward to providing a native client. Also, it makes the maintenance of these libraries a little bit more realistic over time. DockYard has limited resources. We're, by all intents and purposes, still on the small side of agency. We're somewhere in the 70s or low 80s. I forget where we are in terms of headcount right now. And a large agency is going to be the thousands of people. We want to get back up to 100 plus engineers, hopefully over the next, personnel in the next year. But that still puts us in a very unique position in that we aim to reinvest 10% of our revenue back into R&D, which is a lot of money for a consultancy. Consultancies have very thin margins compared to product companies that are profitable. So all that to say, it would be great if we could find some other companies that believe in this project to help us bring it through. Because I think that what we've done to prove out the viability of this is an important first step. The project has enough potential. I would like to think that DockYard has the resources to carry it through to the end, but that's not the question. It's the matter of time. And yeah, maybe we can complete all these clients over the next year and a half. But if we had more resources, then maybe we're really looking at 6 months. And in this world, it's really about time. When we release a project and tell people about it, they get excited. The longer they wait to have to use it, the more fatigue and the more bored with it they get, regardless of all the good reasons why it may be taking time. So I'm very much aware of it. I know that risk. I know that cost. And we're doing our best to try to build out the team to produce these clients built to a particular quality that can be used and relied upon in production situations by large companies. But I'd say like any other open source project, we need help of the community. And so anyone that's out there that has Swift UI experience, specifically because that's our first major target, and it's going to dictate how the rest of these projects should be organized into the scope of which they're built. Reach out. If this is I'm hoping going to be a highly visible open source project. So if there's companies out there that want to, help out and get their name attached to it, this doesn't need to be a DockYard solo effort. We're very much open to and willing to share the rewards of building out a project such as this.
I would love to take a look to see if we can do something for Flutter, because this is super exciting.
All right, so I think this will be the interesting debate part of the conversation. So we looked at Flutter very early on, and I rejected it for a couple of reasons. Number one, I have no faith that Google is going to continue to support projects over a multi-year period. Google has a very bad reputation of abandoning things, and most of Google's open source projects really depend upon Google willing to continue to pump money into it. Number two, whenever I see these cross-platform solutions, it always has never felt great. And I mean, I'm saying that having done PhoneGap, Cordova applications in the past. I mean, I did Ruby Motion a long time ago. I played a bit with React Native, and they all seem to want to find like the one way to build the application that's going to work across devices. And that's never resonated with me. I think that the UI frameworks for these devices, I mean, Apple updates and changes theirs every single year. That's a massive moving target to constantly have to get ahead. And I'd rather build out and target specifically for those frameworks and those experiences that are meant specifically for that device, because I always feel that's going to provide the experience most desired by the users of that hardware. Now, I have to admit, I did not spend a lot of time with Flutter, just that I looked at it from a high level and rejected it for those reasons. But this does not prevent anyone from going and creating a Flutter client either. Like that I think would probably have, people are clearly using Flutter and would have huge value. Just that for our purposes, we went and decided to target closer to the metal of the devices specifically to provide those more, I'd say, bespoke experiences that we hope to deliver and develop as a consultancy.
Yeah, I see exactly what you mean. I was on the same path when I first heard about Flutter, but after playing with it and using it in production, it's been a pretty great experience. Like I'm sure you played around with React Native before, right?
A little bit,
It
yeah.
was probably one of the worst experiences I've had in my life. Yeah, it was horrible. So like I was very much like, we're never going to do this stuff again. And then now I'm kind of like, similar how you're betting your company on Elixir, I'm betting also on Flutter, and it's been working out pretty okay.
Yeah, I hope everyone the best. Just that I've been bitten by the Google thing too many times. You know, I not to say I put any resources in our company behind it, but I was a big fan of Wave when it came out. And there's too many like Google's starting to feel like the Netflix of product companies, right? It just cancels the product. We don't get any closure on it, and it's unfortunate. I mean, it's beyond meme at this point. I remember it probably still exists, like the Google graveyard. So I hope that I'm wrong about Flutter. Just that for me, it felt like it was too risky to bet my company on.
Yeah, I understand, and that's okay. Maybe we'll see what happens, right? Maybe someday you'll change your mind, and that's okay. I've changed my mind about plenty of things, right? So Elixir, I also heard of it, and I was like, what do I need that for? It's another programming language, right? But now I basically don't do anything web unless it's Elixir, and it's total sideways different thing. I was all Ruby in, and that was it.
I mean, I thought it was going to be a web developer. I thought I was going to be a web developer for the rest of my career, and here I am doing native stuff. So, I mean, definitely open for changing a mind. But like I said, there's nothing blocking Flutter from a Flutter client being written, and it's completely viable.
I'm going to kind of go back to what we do know, right? So you know very much about how Swift UI works. How similar, you're saying this, actually the process is very similar for Jetpack Compose, right? It's nearly about the same for how everything kind of works.
Yeah, the clients, I believe so I wrote the original Swift UI prototype for LiveView Native about a year and a half ago. And I was learning Swift alongside trying to implement this, which was an interesting experience. But the original implementation was a naive one in that I effectively wrote functional code in Swift, meaning that there was no instances. I was just writing like class level functions. And the thought behind that was so in the LiveView library, there are Elixir implementations of the JS clients, meaning the MorphDOM JS client and the LiveView JS client. And these are used in testing functions. So if you're building out a LiveView application, your test suite, you want to be able to run integration tests on your LiveView application. But the LiveView core team decided to go in the direction of not standing up a headless browser to run it. They just re-implemented in Elixir the necessary functions to run and interact with the LiveView application. So it's simulating kind of not necessarily a browser, but simulating the interactions and the events. all that to say, it was actually a very good path forward for cribbing off of. So the first pass in Swift was a one-to-one reimplementation of the dom.ex and client proxy.ex files within the LiveView project. And since then, the engineer that has taken over my work, pretty sure he just did rim-rf on the project and started from scratch, but he rewrote everything in idiomatic Swift. So all that to say, to answer your question on how similar the implementation is on the Kotlin side, I would say functionally it's similar, but the implementation could be unique to what makes sense to do in Kotlin versus what makes sense to do in Swift. Which is part of the reason why I think extracting that common functionality out into a single library that just gets shared by the other projects is important, because those implementation details are always going to require someone more knowledgeable in that given language. And that to me feels like a problem long term. This type of project and this type of effort, I think the biggest risk to it is that we have to carry and involve a lot of experts in other languages that we are not experts in. And that has cost. I mean, when you have one Elixir team managing all of like the Phoenix projects, then you can have people bounce between the projects very easily. But if we have the LiveView native clients, one is Swift, the other is Kotlin, another one's C#, you can't do that necessarily. So you need to have essentially separate teams managing every single one. And that ends up being very expensive. And so any opportunity we have to extract out and take those troubles off the table and bring them into one implementation is an optimization I'm willing to go with. So while we currently have those functions implemented in the native languages for the devices, hopefully in the next, maybe by the end of the year, we'll have things extracted out to a Rust library that we can pull into each of the projects. And I'm saying Rust right now, kind of naively. I assume just because Rust is LLVM, we can target LLVM compilation, that we'd be able to pull in LLVM built things with Swift and with C# and with Kotlin. If not, then we will just go straight C for the implementation.
Yeah, I'm just kind of curious about I'm guessing you're going to use some kind of FFI bridge or something to talk between the two languages, right?
Possibly. I haven't even started to research how best they, outside things interact with Swift projects or, the other implementations. If that's the best way to go, then that's what we would do. We just have to, not only do we have to build that, but really document it very well and provide good guidance on how others can bring that project in and wrap it properly and get what they need exposed from it to run their given native client.
Well, the reason I ask is if you're going to be going between, say, Swift, or definitely let's just stick with Kotlin, right? Kotlin is usually going to be running on a JVM. And I know you can also go native too, same with Swift, or I don't know if Swift ever actually has a VM or not, but I know that it also compiles to native. I'm curious about if there's going to be a cost of switching between, the native Rust or C implementation going back to the language, right? Because there are two different.
Oh, you mean going through that boundary layer?
Exactly, yeah.
There could be. I mean, we'll have to measure it and see. But I mean, there's always a trade-off, right? That's for those that are kind of at the beginning or maybe, not too deep into their career, that is the number one rule that doesn't change in software development. There is always a trade-off. For everything that's good, there's always going to be something that comes with it that may be bad. You have to figure out where that balance is and what's in your favor. And to me, even if we lose some performance, it's so no one's going to do a 1 millisecond update. That's not that's like a wildly impractical example just to demonstrate, the performance of this. No one's going to do that in reality. And so I think we have probably a lot of performance budget to eat into in order to optimize this in a way that is a net benefit to all the projects.
I would like to kind of talk a little bit more of what's the kind of immediate milestones coming up for this project?
Got to clean it up. I mean, running to the conference, you can imagine there were a lot of get it dones as opposed to get it done right. And we needed to demonstrate that not only is this functionally working, but we have a tutorial stood up. So public API, we really need to go through and start to codify this. Right now in Swiftland, when you style a component, it's called modifiers. I actually don't remember if Jetpack Compose has similar terminology. It might. But modifiers are essentially the Swift UI components, the instance of them. They're just function calls right off of it. And so you can chain the function calls, but it just returns the instance of the view. And then you call the modifier, it modifies it, but returns the instance again. And we really need a good way to represent and build these out properly. Right now, a lot of this stuff is hard-coded per component on our implementation. And that is technically possible for us to just grunt work our way through it. But we got to find a better path on the organization of the code. I also am very dedicated towards covering the Surface API of Swift UI, but only Swift UI only. And we've had a lot of asks on, is this UI kit thing going to be in there? Or is this other thing in the Swift, in another UI example on the Apple documents going to be in there? And the answer is, if it is in Swift UI, we will most likely include it in the Swift UI client. But that is the surface layer that we're going to just cover in the Swift UI client. What we would like to see are for those other UI kit, there's no reason that you can't build out a component system of UI kit that now registers itself with the Swift UI client. The other thing too with these clients is that we want to allow for custom components to be usable. So in Swift, there is no sense of reflection at runtime. So we can't just reflect on it and say, hey, this naming convention from this element corresponds, and we should be able to discover this component name based upon it. We have to have essentially a key value pair, like a one-to-one mapping that's available at compile time. So we have a registry system that we've built out. And when you're building complex Swift UI applications, you're very rarely working with the direct base level components. You're kind of incentivizes you to create your own custom components comprised of other components. And we want to provide a similar experience where you're building up components in the Swift side of things, or much better, people are distributing and sharing their common components that you can now pull in as dependencies that plug right into your Swift, your LiveView Native application. And so you're referencing these higher level, more abstract components as opposed to the base metal components. That's where we feel like a lot of the performance gains are going to be made in prototyping and building out applications. So I kind of went off on a tangent there. I'm not sure if I answered your question because I don't actually recall what the original question was.
The question was what's going to happen in the immediate future for LiveView Native?
Oh yeah.
We talked a lot about what's going to happen in the way future, right, with the Windows client and many other things, right?
Like I said, we got to clean up the project. We got to start putting it on the path towards here is what the real 1.0 API is meant to be. And I've allowed the engineering team a lot of latitude to date on what the implementation was, because there was a lot of experimentation. And so for those that manage and build product teams, managing an R&D department is almost the complete opposite mentally. You have to allow them to go and maybe spend 2 weeks trying something that's not going to work. That's just something you have to accept. They have to have the ability to go and experiment with that. And so setting estimations around it and stuff are really difficult to impose and usually fail. As long as you're trusting that they're continuing to move forward and showing some progress. But those experimentations come with, they sacrifice on and shouldn't be trying to impose code quality on the project at the time, because they need to try something out. They think, does this work? Does that work? What can happen here? Is this interesting? The guy implementing our Jetpack Compose client actually implemented the Canvas component, and demonstrated with a LiveView native application, objects moving on screen and animating. And I was like, oh, wow, that's actually possible. I never really thought that. I thought outside of productivity type applications, there would be very little use for LiveView Native, but who knows? I think that the point here is that this programming model is so new and there's potential to try to apply it elsewhere. And I don't mind experimenting with that for now and seeing what is possible. And if something doesn't work, okay, but we maybe learned something from it, or at least eliminated that as a possibility. But all to say, I'd say over the next 3 months is going to be spent really trying to get the Swift UI client on track towards what will be template for other clients to base themselves off of, and starting to get to the point we are building out interfaces where the components themselves, it just becomes a game of like whack-a-mole on the list of components we have to implement. There's definitely got to be some thought as to implementation details on some of the components, because they're not all as simple as just like the text component. But and we also have to build out the event system. So right now, I think we just have like the PHX click events, which is the attribute you put on LiveView elements if you want to respond to like clicking on it. There's a lot more bindings that exist in LiveView. We just have to go through and implement them, but we have to implement them in a way where we're not re-implementing them on every single component. We have to essentially have a common functionality that we can either pull in, inherit from, or that just gets abstracted out at a higher level. And right now, what we have implemented is a lot of hard coding per component, which is good for us demonstrating this, but it is not a viable path forward in terms of a sustainable framework. So there's going to be a lot of work over the next few months on getting everything on track towards how do we move forward to a 1.0 at some point.
Now, I kind of want to finish up this because we've been talking for about an hour right now. I know you're a busy guy and it's working day for you, right? So I kind of wanted to end like this session where we kind of talk about what would this technology be good for and what would it not be good for, right? Because I can imagine like if your users are not in a good like place or that they can't always be connected, then this would not work, right? This particular technology.
As it is implemented today, no, it would not work. It has the same limitations that LiveView Web has, which is that offline mode is not supported. The kind of pushback that Chris McCord has on Phoenix, and I think is a valid point, is there are very little web applications that have offline mode capabilities. Even the Google products, like Google Drive products. I see things. I used to remember docs working offline at some point, maybe very early on, and I play with it again. Its offline like support is terrible now. Gmail, like you'd expect there to be good offline support, but no. And it's kind of like this broken, janky experience. However, offline is a bit more accepted as being, or a bit more expected on native than it is on web. However, the current implementation does not support offline mode. However, and here's this is where it gets a bit crazy because it can kind of feel like Elixir Russian nesting doll. There is another project called Elixir Desktop, and Elixir Desktop allows for the the Erlang virtual machine, the Beam, to be compiled and packaged up to run on device, meaning that you can build an iOS project that is running the Beam. And you can interface with that runtime. I haven't built an Elixir desktop application, but I know that you can interface and ask it for things, and it'll give you things. And so a friend of mine, Garth Hitchens, he's the one that brought this idea up to me because he built out a Elixir desktop iOS application, and it uses WX widgets for its UI rendering. Now, wouldn't it be interesting if Elixir Desktop was hosting a Phoenix application running on your mobile device, and at runtime it was your first kind of interaction was directly with that local running Phoenix application, and it was running out LiveView Native, and so the components were rendering native components. But that Phoenix application on your device was actually a node to a cloud-based Elixir, Phoenix backend or something like that is part of a cluster. Now, when the device that has low or no connectivity, it will be able to reconnect in the future and resynchronize that data appropriately, but it will still allow you to continue to operate on the device, on the phone. And the really nice thing about this is that we'd be looking at probably a memory footprint of like 30 to 35 megabytes compared to React Native, which is above 50 megabytes just to get started. The other kind of potential thing here is with Firefly, the WebAssembly target, the WebAssembly compiled Beam reimplementation that we're currently doing. I just spoke with the head of that project yesterday, and what we're going to try to do at some point is swap out Beam compilation with Firefly compilation on Elixir Desktop. And at that point, we could theoretically bring the the install size well below 5 megabytes with potentially no downside. Now, the downside there is that as a compiler, it's brand new, and I'm sure there's going to be a lot of things that are not accounted for yet compared to the Beam, which is, or Erlang, which is 30 years old, so more battle tested. But and this is why I say it's like Russian nesting doll of Elixir, because we're saying, hey, we're sticking Elixir inside of Elixir and into a container that's running on your device. But if we can nail it and nail the development experience in a way where those implementation details aren't really things that you're having to deal with, they're just part of like the build process of building your Swift or like your native application, then that's a win. And that's really kind of one of the acceptance criteria that we're trying to nail here, is that I've told the team that a junior engineer should be able to be productive with this. To do this stuff, you should not require like 10, 15 years of industry experience. You shouldn't need all this esoteric knowledge. You should be able to come through a code school and be able to be effective in building with these applications. And if we're not meeting that acceptance criteria, I think that is probably our biggest risk for the success of the project. I think that's just good challenge for any development project that wants to be successful. Like even like the more technical you go up the chain, let's say machine learning, the first machine learning implementation that makes it easy for junior engineers to build machine learning applications is going to be the winner, hands down. Like that's just the way it works in our business. It's not about who is the fastest, not about like technically most capable. It's about who is the easiest. So that's something that we're trying to keep in mind with the eventual final product.
Yeah, and I can say for sure that Elixir is not very easy for people to pick up. Even Swift is also not very easy for people to pick up too. But for some reason, like React Native is usually relatively easier, right? I mean, JavaScript is just, the amount of material out there for JavaScript learning is huge.
Yeah, it is. And I'd say that in many ways, React, I view it as a competitive threat to Elixir as a technology. React isn't a language, Elixir is, but React is effectively an ecosystem at this point. You have companies that will want to go with React because they can use it full stack. They can produce their web front end with React. They can produce their native clients with React. And now there's the React server effort. And so whether it's production ready yet, I don't remember. It's the one that Ryan Florence is building. I don't know what the current state of it is, but either now or soon, you'll be able to build out your server side in Node with React. And that means at that point, you'll be able to hire and keep your whole stack in React, hire just React engineers. And this is something that I think if you're passionate about your particular language or framework that you should be aware of is happening, is that React is slowly eating up and creating less reasons or more reasons to continue to use it and grow its kind of, its tentacles into your organization. And so to that end, the way I look at it is Elixir needs to respond, and we have a server side implementation in Phoenix. We have the web implementation in LiveView. And so it makes sense for us to go ahead and cover the last remaining ground there, being the native implementation client. However, our direction and while React Native most certainly was an inspiration for this project, and as I indicated earlier, this project wouldn't be possible without React Native, because Swift UI and Jetpack Compose appear to have been heavily influenced and maybe even ideated because React Native proved that composable UI made sense to do on native. Our approach is almost polar opposite. Whereas React Native is everything runs on device, we're server rendered. Whether or not you have that server on your device, we're still a server rendered framework. React Native went for one unified UI across all devices. We're relying upon the actual UI frameworks of those devices. So we do that, as I indicated before, because it means that we can stay closer to the experiences that are expected on these devices. But in addition to that, it also frees us up from having to do all that extra work. And so we can be faster to respond. We can catch up more quickly, and we can just punt on documentation. Like, we're not going to reproduce all the Swift UI documents. Like, it doesn't make any sense. We're just going to say, here's the naming convention. You go over to the Swift UI docs, you find the corresponding component that you want to use, and here's how you mentally convert it over. At least that's my idea on how simple our documentation will hopefully be. We'll see how that works in the real world. But the bigger picture is that we're not taking on as much work as the React Native team needed to take on to do what they did. And I don't want to undersell what they accomplished because it's astronomical, but I think it required a company such as Facebook to fund that effort. What we're accomplishing, I think, from an end user's perspective, is going to be transparent in terms of complexity, but we're doing a far smaller scope of what we're trying to accomplish. But its impact could be, hopefully as wide-ranging as React Native. We may actually, theoretically, could have a wider impact, being that we're targeting a Swift UI and Jetpack Compose, and these UI frameworks are intended to work across multiple hardware targets. Whereas React Native, I know that it will do like desktop and mobile. I don't know if they have that function for targeting like tvOS or watchOS at this point, because they're not, to my knowledge, they're still using UIKit and Objective-C under the hood. That could be different. I could be wrong on that. I just haven't really looked into it in over a year in terms of how they implemented everything.
Yeah, I know React does a lot more than what I thought. I thought it was only for iOS and Android, but apparently they also can do much more than that. Even web, which seems a little bit weird. That's like, oh, wait a minute, you're React Native, but then somehow you go to web. This is getting weird.
Yeah. So we have a lot of work to catch up to them. But as I said earlier, I don't know if DockYard on its own has the resources to achieve that goal. We're going to do our best, but any companies that are out there that find value in this project, we could certainly use the help.
Okay. Yeah, that's what I wanted to go to next, is kind of like a quick signing off. And because, again, we used up a lot of your time. Obviously, you've made many, many pleas for people to kind of come on and help out, right? Maybe you want to reiterate that, or how can we actually help out? I mean, besides just committing code or whatever, I mean, I think documentation would be huge too, because if you go to LiveView Native, the site you have, it's very, it's missing some more information.
Yeah. Okay. So the native.live site is like bare bones marketing landing page that we basically just got stood up right before the conference. Where you want to go is the LiveView Native organization on GitHub. So github.com/LiveView Native. And then on there, if you go to the Swift UI client in the README, there will be a link to the tutorial. I mean, that's kind of a roundabout. We should probably just put it right on the website. But that's how you get to the tutorial right now. And this will step by step, step you through building out a LiveView Native application for Swift UI. It's a very basic app, but it will show you how to render UI elements. It'll show you how to do list views. It'll show you how to do button interactions. It'll show you how to do navigation. It'll show you how to load asynchronous images. That API is going to change and modify as we start to really figure out how best to implement this. But as far as people coming from the outside to help, we need experts in building Swift UI applications that know how to organize those projects in the idiomatic way that Swift UI projects want to be implemented. Like I tend to reach for, like, how would I build this in Elixir, or how would I organize it in Elixir? And that may not actually make sense. Like, it may be best to say, here's the idiomatic project structure for a Swift application. Here's the idiomatic project structure for a Kotlin application. But the point is that we need to implement consistency. We need to, someone that wants to contribute to the project shouldn't have to go through and figure out all the weird things that we've done. There should be structure there, and it should be easy to follow. And as far as the higher level abstract needs right now, it's like abstracting out, how do we apply modifiers? How do we do events? I have an idea on how, so in LiveView, when it comes to more like client-side interactions, there's a system called JS commands. And this is simply just a way for you in the LiveView template to say, this JS, like doing this thing corresponds to this JS command. And of course, we can't do remote code execution on Swift, for iOS applications. And we don't want to try to upset Apple and say, hey, this framework is no good. And so I have this idea on maybe supplementing that with an event system where you can register events on the native side of the application. And then in the LiveView template server side, you can kick off a given event and pass in some parameters to it. So anyway, there's a lot of ground to cover, and there's a lot of opportunity right now to help influence how that ground gets laid. So that I'd say more than just pushing bits, helping think these things through is probably the biggest impact someone can make right now to the project.
And if they want to like help out, like should they have to ping you on the Slack or just start committing code and pushing up stuff?
So I think what I'm going to do is maybe we have to have some place where we can communicate, and that may be best for the GitHub issues for now. So we have some issues already being open, asking about this thing, that thing, and I'm trying to respond when I have a moment or, I have some thoughts on it. But it's not like under formal management at the moment. That's something that we're going to be working on in the next, actually, I hope this week to start kicking that off. We got to find, I would like to have more regular core team meetings where we can, record and discuss, and then allow people that want to join to come in and join and share their thoughts. I will say that I'm pretty, I can be narrow-minded, or not narrow-minded, that's too negative. I say a bit more tunnel vision at times. And not every idea is always, whether or not it's a good idea, it may not always align with the vision of the overall project. So I would say that even if you have a good idea and if it's rejected, don't be discouraged by that. It's not a combination of what you're thinking, just that it may not. Sometimes there can be two right ideas that pull something in two different directions, and so we have to go with one. The other side of it too is I think the first kind of experience is really focused on the Swift UI implementation. Even though we are moving forward the Kotlin one as well, it's more that we need to kind of figure out a lot more on the Kotlin side, on the Jetpack Compose side of things. Like we're much further behind on that than the Swift side. But I'm hoping that a lot of the decisions that we make, I don't want to start making decisions across all the projects right away. I think if we focus on and be specific to the iOS one right now, some of those decisions can actually inform and require less work around decisions being made for the other projects in the future. Like we have to be very careful about not just doing what's in the best interest of the Swift client, but also being aware that these decisions can impact the larger ecosystem that we're hoping to build up around this.
Okay, yeah, this is looking pretty exciting, right? I'm already thinking about things that would be nice. I can't imagine how many times where I've deployed an application and the client's like, no, this is wrong, or there's a bug, and it'd be nice if we just had everything on the server, just deploy an update, and that could fix some issues. It's always around content usually.
So we did that at ElixirConf.
Yeah, I saw that.
Yeah. So for those that don't know, at ElixirConf, we launched a chat application, which was a very, 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 very basic chat application. And it was probably like about a day's worth of work of like pure focus on the chat app. And it was probably a week's worth of implementation time, just because this is the first real LiveView native application that we were submitting to the App Store. So we spent probably more time going back and addressing issues in the client than we were building the actual app functionality. But we had a bug in it. And I'd like to say that bug was by design, but it was not. It was just a bug where the people count was not decrementing when people were leaving. And so we had the application pushed and installed and approved by the App Store, I believe, the morning before the conference, morning before my talk, so Wednesday morning. And then it was distributed to the conference later on in the day. And so, some people installed it. We did not tell people it was LiveView Native beforehand. And during my presentation, I basically surprised everyone, say, hey, you've been using LiveView Native the whole time. I wanted to have that moment where people are saying, oh yeah, these slides are nice and good, but when can I use it? And we said, you can use it right now. Like, we're releasing all this open source, and there is an example of this application functionally installed on some of your phones already. But we were able to push an update to the Phoenix application, and we did the fix. Took less than 5 minutes for one of our engineers to fix. Push it to fly.io, about a minute to deploy, and it was immediately, because of the way, even if you had the application open, LiveView as a client will sense a disconnect on the server, and then when it reconnects, it will re-render the updates appropriately. And so that update was immediately available to everyone that was connected, whether or not we had 5 people connected, but if there were 1 million people connected, they would have received the update immediately too, which I think is a very powerful thing, but it's also one we have to be careful not to abuse. Apple does not like significant functional changes happening without their review, which I understand. It's their app store. But I think for content updates, if there's like a critical bug, like if you did something where like, oh, we're charging $1 instead of $10, you don't want to wait a few days for App Store review, to get that pushed up. And if you have a good relationship with Apple, maybe you can get, through the review process more quickly. But very few companies are in that position.
Yeah, definitely. I think everybody's had that problem. I mean, you probably spent 10 times much time with Apple than you did on the actual Elixir app, right? When you built it.
Well, we like Apple. Apple's one of our big clients. I do think that the review process is a bit, it's a different thing than what I'm accustomed to being on the web. We press the deploy button, good to go. And in Apple world, it takes time, and my understanding of the Google Play Store is that it's significantly less time for review. But, maybe that results in lower quality, applications getting through the door. I don't know. This is by and large a new space for me. And I've been a consumer of this space, not a producer in this space. So I'm learning a bit about it as we go.
Okay. Well, thanks again for coming on and talking about LiveView Native. I'm happy to see something like this. I'm curious to see what's going to happen. Hopefully this will be something we can actually see in a lot more apps nowadays. And maybe this will be pushing Elixir much farther.
Yeah. We want to try. We'll probably have Dockyards marketing department involved with producing regular communication as to updates that are occurring. I know that the worst thing that can happen right now is us just to go dark and disappear for a few months. People left wondering what's happening. So even if there's small changes, as long as we're demonstrating that we're committed to the project and we're continuing to push it along, this update, this week we did this update type of thing, I think is going to be important for us to stay on top of.
Awesome. I'm looking forward to hearing about this because this is exactly what happened with Lumen, right? It was a really big announcement and then it kind of like fell out, right? But I'm happy it's back.
Yeah. Well, I mean, just to address that for a moment, that's exactly what happened. That had the unfortunate timing of it being around the time I left DockYard. And when I left, some other engineers also left, one of which was on the Lumen core team. So things kind of got out of control there. But when I came back, I tapped that engineer and said, let's get the band back together. He was all for it. And I'm dedicated to getting that project completed. And so I'm very much aware of it being viewed a bit as ghostware or vaporware. And that's a valid criticism. But I'd say give us the opportunity to prove you wrong on that. And I think that we're getting closer to it. We have a lot of what's happened on Lumen in the past 2 years, on WebAssembly in the past 2 years have addressed many of the things that we are having to work around in Lumen. And so Paul has spent the past 6 months rewriting a lot of the compiler to align with modern WebAssembly spec. And I believe he has a basic compiler working at this point. So we can take Elixir code and compile it to WebAssembly. It's not really in a position that you want to do anything with it at the moment, but it's significantly further along than it was when we presented it at ElixirConf back in 2019.
Yeah, because before it was Erlang only, and now you can actually do Elixir right now.
Well, I think at the time we presented it, it wasn't even Erlang only. We had to write the bytecode by hand and present this to the Lumen compiler. It took the Erlang bytecode and compiled that, but there was no way to take the syntax and bring that through the compiler. But now it's taking it from the original Elixir source and compiling it. There's a lot of work to do on covering the ground for the runtime stuff, but it's on the right path at the moment. And I'm being very careful not to put expectations for dates around it because this never works out very well. So just saying that I hate to give like when it's done, which is like the video game response, but that's really what we're focused on. We want to make it a good product. We want to, if you look at if you go to github.com/getfirefly, you can watch the project on there. Paul is making regular commits to it. He tends to do like mega commits, and so it may be a week or two between commits, but he's making them. And Elle, who was working on the runtime, she rejoined the project back in July, and we should start to see, hopefully, something. I'm hoping that we're going to have be in a place sometime next year where we can share it at a more higher level and say, this is what we've accomplished. This is what you can do with it.
Now, what I understand, because I had a separate podcast interview with Paul on actually a Rust podcast. What I actually understand too from Paul is that you guys have actually pushed a lot of stuff into WebAssembly yourself, because I guess he said that not a lot of people were actually joining these committee meetings, and so people were proposing things, but then nobody was kind of saying, yes, we need that from some other languages.
As I understand it, the WebAssembly specification meetings are highly dominated by the browser vendors for good reason, right? But they were mostly focused on the needs of their languages. So Rust, C, JavaScript, the needs of these languages to compile to WebAssembly are highly represented in the specification. But when it comes to functional programming languages, they were extremely underrepresented. And I believe we may have been the first group to join the committees or start attending the committee meetings to represent functional programming language needs. And since then, I think Haskell has gotten involved, and there may be some others. But the big thing with the Beam is that we can start up many tiny processes very quickly, right? And so the WebAssembly group is like, oh yeah, you can just start up.
This is the web workers, right?
Yeah, web workers. And we're like, no, web workers are big fat. This is not an analogous solution. And so I think I still don't think that has been solved yet, but at least some of the needs we require to perhaps create our own process management system have moved significantly in the past 2 years for us. There's I'd say a better path forward for functional programming languages to be viable in WebAssembly today than there was 2 years ago. So we were, like I said before, we were having to work around a lot of the deficiencies in the specification and be kind of clever about our implementation to do what we needed for Erlang on the web. And now I believe many of those blockers no longer exist. So the past 6 months, again, have been spent trying to bring the code up to what is currently possible. And I know that there are even some new things on the horizon with WebAssembly that give us even better position in the near future. It would probably be, I don't know when you spoke to Paul last, but it may be worth having him on again just to chat with him, because if it was back when it was Lumen, there's probably a whole bunch of new things for him to talk about that I'm talking about it on a high level, and he's going to have all the dirty details around those things.
Yeah, maybe we will. I'll have to see if he's interested. So, okay, cool. Again, thanks for coming on. I'm hoping to see more of what's going to happen, and let's see what happens. Yeah.
Great.
Okay, it's very exciting.
Thank you.